Hello everyone. In this video, we're going to discuss and solve problems involving derivative of inverse trigonometric functions. But before that, let us first discuss the different formulas that we are going to use when we are dealing with inverse trigonometric function. So say that we are given u as a function of x and the given function y is equal to arc sine of u. So again, u is a function of x in here, and if we're going to solve for y prime or the derivative of y with respect to x, then this is now equal to the derivative of u with respect to x all over the square root of 1 minus u squared. So this would now be the formula for the derivative of arcsine of u. For arctangent of u, if we are given y equals arctangent of u, where u is a function of x, then y prime is now equal to the derivative of u with respect to x all over 1 plus u squared. And for function which is y equals arcsecant of u, y prime would be equal to the derivative of u with respect to x all over u multiplied by the square root of u squared minus 1. Right? So this would now be our formulas when we're given derivatives of arcsine of u, arctangent of u, and arcsecant of u. So to illustrate this further, let's have this first example. We are given here y equals arcsine of 4x, and we're going to solve for the first derivative of y. Now, in the given function arcsine of 4x, this 4x would be our u. And if we're going to recall our formula, the derivative with respect to x of arcsine of u, that is equal to the derivative of u with respect to x all over the square root of 1 minus u squared. So if we're going to apply this formula to the given problem, then y prime would now be equal to du, or that's now d over dx of 4x, which is our u, all over the square root of 1 minus 4x quantity squared. And if we're going to simplify this one, the derivative of 4x is equal to 4 all over the square root of 1 minus 4x quantity squared, so that will give us minus 16x squared. So this would now be y prime. For our next example, we are given y equals arctangent of 3x, and we're going to solve for y prime. So again, the formula for the derivative with respect to x of arctangent of u, where u is a function of x, is equal to the derivative of u with respect to x all over 1 plus u squared. So 3x in the given function would be our u, and solving for y prime, this is now equal to applying the formula in here. So we have the derivative with respect to x of 3x all over 1 plus 3x quantity squared. And simplifying this, y prime is now equal to the derivative of 3x with respect to x is equal to 3 all over 1 plus 9x squared. Since the resulting expression cannot be simplified any further, so this would now be our final answer. For our next example, we are given y equals arctangent of x over a. We are going to solve for dy over dx. So if we're going to inspect our given here, we have three letters, alright, that might be a variable, but since dy over dx is the requirement, then we're going to treat a as constant. Alright, so we're going to treat a as constant. And since this is in the form of arctangent of u, so if we're going to write the formula here, the derivative with respect to x of arctangent of u is equal to du over dx all over 1 plus u squared. So if we're going to apply the formula, y prime or dy over dx is now equal to the derivative with respect to x of u, and u in here is x over a, so that would be x over a all over 1 plus x over a quantity squared. Now, this is now equal to the derivative of x over a, where a is a constant, that is now equal to 1 over a, all over 1 plus, this would now be x squared all over a squared. So if we're going to simplify this resulting expression, we now have 1 over a all over, right? So if we're going to combine the two terms in the denominator, the LCD would be a squared. So a squared divided by 1 times 1, so that would be a squared plus x squared. Now, a in the denominator of the numerator will cancel out with 1a in the denominator of the denominator. And the resulting expression, or dy over dx, would now be equal to a all over a squared plus x squared. So this would now be our final answer. So for our next example, we are given x equals quantity arctangent of t squared, and we're going to solve for x prime. Now x prime in here, since our independent variable is t and our dependent variable is x, then x prime would be dx over dt. So the formulas that we are going to use in here would be the derivative with respect to x of arctangent of u, which is equal to du over dx all over 1 plus u squared. And since the whole arctangent of t is raised to 2, then we're also going to use the formula u raised to n. And this would now be equal to n multiplied by u raised to n minus 1 du over dx. So if we're going to solve the problem, dx over dt is now equal to, we're going to use this formula first because this is in the form of u raised to n. And since that is u raised to n, so that would now be 2 multiplied by arctangent of t raised to 2 minus 1, or that's basically equal to 1, multiplied by the derivative with respect to x of arctangent of t. Right? Now, for this one, we're going to use this formula. So, this is now equal to 2 multiplied by arctangent of t multiplied by the derivative of arctangent of t, which is equal to the derivative with respect to t of t all over 1 plus t squared. So, the derivative of t with respect to t, so that will give us, right? So, let me just rewrite this one. The derivative of t with respect to t is equal to 1 all over 1 plus t squared. And if we're just going to simplify this one or arrange it, so this will now be equal to 2 arctangent of t all over 1 plus t squared. This is now dx over dt. Let's have another example here. We have y equals x squared arcsine of x, and we're going to solve for y prime. Alright, so in this given function, if we're going to inspect it, we have u times b, right? So this is in the form of u multiplied by v. And the derivative with respect to x of u times v is equal to u dv over dx plus v du over dx. And since we have u raised to n in here, and we also have arcsine of u in here, so the formulas that we are going to use would be the derivative of u raised to n is n u n minus 1 du over dx, and the derivative with respect to x of arcsine of u would now be equal to du over dx all over square root of 1 minus u squared. So this would be the formulas that we are going to use. And solving for y prime, right? So if we're going to solve for y prime now, this is now equal to, since the given function is in the form of u times v, we're going to use this formula first. So that would now be equal to x squared multiplied with the derivative with respect to x of arc sine of x, right? So plus arc sine of x multiplied with the derivative with respect to x of x squared. So this would now be equal to x squared multiplied by the derivative of arc sine of x. So we're going to use this formula we have in here. So that would now be derivative with respect to x of x, because u in here would be x all over the square root of 1 minus x squared, plus arc sine of x multiplied by the derivative of x squared, and the derivative of x squared is equal to 2x. So if we're going to simplify this one, that would now be x squared multiplied by 1 all over the square root of 1 minus x squared plus 2x arc sine of x. And if we're going to combine these two terms, so we now have the LCD would be square root of 1 minus x squared. So the LCD divided by this term multiplied by x squared, so that would be x squared. And this would be plus 2x arc sine of x multiplied by the square root of 1 minus x squared. So if we're going to simplify this any further, we can bring out x. So that would now be x plus 2 arc sine of x, alright, multiplied by the square root of 1 minus x squared, all over the square root of 1 minus x squared. So this would now be our final answer. So let's have this example here. We have y equals quantity x minus 1 multiplied with the square root of 2x minus x squared plus arc sine of x minus 1. We're going to solve for y prime. Now, since we have two terms in this given function, and we have arc sine in here, and we have a product in here, one technique that we can do is to determine the derivative of each term independently. So if I'm going to let this term be equal to a and this term be equal to b, then we can solve for y prime be equal to a prime plus b prime, or the derivative of this term plus the derivative of this term. Alright? So solving for a prime, a prime, or a, which is x minus 1 multiplied with the square root of 2x minus x squared, is in the form of u multiplied by v. And u multiplied by v is, the derivative of u multiplied by v is equal to u dv plus v du. Alright? So square root of 2x minus x squared can also be written as 2x minus x squared raised to 1/2. So if we're going to solve for a prime, then this would now be x minus 1 multiplied by the derivative with respect to x of 2x minus x squared raised to 1/2 plus 2x minus x squared raised to 1/2 multiplied with the derivative with respect to x of x minus 1. So this is now equal to x minus 1 multiplied by the derivative of this one, alright? So this is in the form of u raised to n, and u raised to n, the derivative of that would be n, or that is 1/2, multiplied by 2x minus x squared, so that is u, raised to n minus 1, and 1 half minus 1, or yes, 1 half minus 1 is equal to negative 1 half. Multiplied by the derivative with respect to x of 2x minus x squared. Alright, so if we're going to recall, derivative with respect to x of u raised to n, that is now equal to n, u raised to n minus 1 du over dx. So applying this formula in this expression, so that would now be 1 half 2x minus x squared, because our u here is 2x minus x squared, raised to n minus 1, because 1 half minus 1 is negative 1 half, multiplied by the derivative with respect to x of u, which is 2x minus x squared. Alright, and for this term, that would now be plus 2x minus x squared raised to 1 half, multiplied by the derivative of x minus 1, so that would now be equal to 1. Alright, so continuing with our solution, this is now equal to x minus 1 multiplied by 1 half. Alright, so that would now be 2x minus x squared raised to negative 1 half multiplied by the derivative of 2x minus x squared, so that would be 2 minus 2x plus 2x minus x squared raised to 1 half. Now, in this term or in this factor, we can still bring out 2, or we can factor out 2, so the remainder or the other factor would be 1 minus x. Now, this 2 here could cancel out with this one. So if we're going to cancel out that one, so the first term would now be equal to, if I'm going to bring out the negative 1 in this factor, so that would be negative 1 minus x multiplied by this 1 minus x here all over, if we're going to make this positive exponent, so it will be in the denominator, so that would now be 2x minus x squared raised to 1 half plus this one would be 2x minus x squared raised to 1 half. And if we're going to combine these two terms, so the LCD would be 2x minus x squared raised to 1 half. So 2x minus x squared raised to 1 half multiplied by this one times the numerator, so that would be negative. The expansion of 1 minus x multiplied by 1 minus x is equal to 1 minus 2x plus x squared. And 2x minus x squared raised to 1 half divided by 1 times this one will give us plus 2x minus x squared raised to 1. So if we're going to collect similar terms in the numerator, this is now equal to negative, alright, so that is negative 1, negative times negative 2x, so that would be positive 2x, plus 2x, so that would be positive 4x. And negative x squared plus negative x squared, so that will give us negative 2x squared, all over 2x minus x squared raised to 1 half. Right? So this is only the derivative of this term, or that is a prime. Now, if we're going to solve for the derivative of arc sine of x minus 1, so that will give us now b, or if we're going to let arc sine x minus 1 be equal to b, then b in here, or b prime, would now be equal to, right, so if we're going to recall the formula for the derivative with respect to x of arc sine of u, then that is equal to du over dx all over the square root of 1 minus u squared. So applying this formula, we now have derivative with respect to x of x minus 1 all over the square root of 1 minus u squared, which is x minus 1 quantity squared. So simplifying this, b prime is now equal to derivative of x minus 1 is equal to 1 all over the square root of x minus 1 quantity squared will give us x squared minus 2x plus 1. Right? So if we're going to collect similar terms, in here, we'll be having 1 minus 1, so that will give us 0. Then this would now be negative x squared, and that would be negative times negative 2x, that would now be positive 2x. Or, we can write this as 1 all over the square root of 2x minus x squared. Right? So that would now be b prime. So solving for y prime, which is equal to a prime plus b prime, a prime, if we're going to go back here, a prime is equal to negative 1, right? So that's negative 1 plus 4x plus x squared all over the square root of 2x minus x squared. So let me just check that one. Negative 1 plus 4x minus 2x squared all over 2x minus x squared raised to 1 half, or that is square root of 2x minus x squared. Alright, so this is minus 2x squared. Plus b prime, which is equal to 1, right? So that is 1 all over square root of 2x minus x squared. Now, if you're going to notice in here, we have a common denominator, so we can combine these two terms. So this is now equal to, the common denominator is 2x minus x squared. So negative 1 plus 1 will cancel out. So that would now be 4x minus 2x squared. Now, if we're going to factor out 2 in the numerator, so that would now be equal to 2 multiplied by 2x minus x squared, and the denominator will be written as 2x minus x squared raised to 1 half, then we can still simplify this one. Alright? So the simplification of this would now be 2 multiplied by 2x minus x squared raised to 1 minus 1 half. Or this is now equal to 2 multiplied by 2x minus x squared raised to 1 half. Right? So this fractional exponent can be written as 2 multiplied by the square root of 2x minus x squared. So this is now y prime, or this would now be our final answer.